For our second sample problem, it says here that determine the magnitude of the resultant force acting on the bracket and its direction measured counterclockwise from the positive u-axis. Okay, so the figure goes like this. So we have two forces. Our first force going there, the direction, it is equal to 200 pounds. So our second force is equals to 150 pounds. And then here is the u-axis. Then we have here the v. Okay, so the angle between the v and the second force is 30, and then the angle between u-axis and the v is also equal to 30 degrees, and then the angle between u-axis and the first force, 200 pounds, is equal to 45 degrees. So again, first let us draw the free body diagram. Okay, so here is the 150 pounds, our second force, and here is our first force. Okay, so in order to suffice the requirement for the parallelogram, let us connect these two forces to form a parallelogram. Okay, so the figure goes like this. Okay, so again, these sides, they are just equal, or they are congruent, and then this side is also congruent. They are both equal to 150 degrees. Okay, so now is next is to determine the degrees. Okay, so a 30 degrees, so we could say that the angle between the second force, 150 pounds, and the u-axis is equal to 60 degrees. Okay, and then the angle here between the resultant force and the first force is equal to 45 degrees. Again, using the a theorem in trigonometry, we know that the angle here is equal to the angle here. Therefore, this is 45 degrees, and the angle is here is also equal to 45 degrees. So how to get the angle here, or when where did this 75 degrees taken or came from? So how did this derive? So these are just basic. So again, so 45 degrees, this is also 45 degrees, and we know that uh, um a triangle is the total angle for the triangle is equal to 180 degrees. Okay, so here is 60 degrees, and here is also 45 degrees. Okay, so 45 plus 60, 45 plus 60 is equals to 105. So 180 minus 105, so the remaining angle will be 75 degrees. So again, the angle here is equal, the same angle here. So if you're going to add up this angle, and then here is this is equal to 105 degrees. So the remaining angle, since we know that a triangle is equal to the total angles for a triangle is equal to 180 degrees. So therefore, 105 or 180 degrees minus 105 is equal to 75. So the angle here will be 75 degrees. Okay, so next. Okay, so here the angle between the u-axis. So if we're going to connect this one, which is for the um, the for the resultant force, um, the angle between the u-axis and the magnitude of the resultant force here is, let's say, designated as the symbol. I forgot the symbol. Phi ba to? Or ganun na yun. So, this symbol. Okay, so let's say, assuming this is theta. The theta between here, the u-axis and the fractional, and the angle between the u-axis and the resultant force. So again, let us recall. Um, so here, the force here is 150 pounds. Here is 200 pounds. Then we have the u-axis here, and here is our resultant force. The angle between the force 150 pounds and the u-axis is equal to 60 degrees. And then the angle between the u-axis and the 200-pound force is equal to 45 degrees. If we are going to compute the total angle between the two forces is equal to 105 degrees. And we know that this is also equal to the angle here, 105 degrees. And the total angles for a parallelogram, or a rectangle, or a parallelogram rather, or four sides, we have four sides, is equal to 360 degrees. So 105 105 times 2 will be equal to 210. So 360 minus 210 will be equal to 150. So if we're going to divide the 150 into 2, 150 divided by 2 is equal to 75 degrees. So the angle here is 75 degrees, and the same angle here, this is also 75 degrees. Now, let us get or take the half portion of the parallelogram, and then the one the triangle. So this is now the 200 pounds, because we know that this one, they are just congruent. So this is at 200 pounds, and then the force here is also 150 pounds. And then here is the required in the given in the problem, the total, I mean the resultant force. So the angle between the u-axis and the resultant force is, let's say, let us assume that this is theta. Okay, and then we don't know also what will be the angle between the force 150 pounds and the total, I mean the resultant force, or the F sub r. So we don't know the value yet. So let us designate the angle here from 150 pounds force to the resultant force. Let's say this is alpha. Okay, so now in order to solve for the resultant force, or our F sub r, using this figure, a triangle, let us use again the cosine law. So again, it is C is equals to the square root of a squared plus b squared minus 2ab c cosine of the opposite angle of side C. So substitute. Let us say that our C will be the F sub r, or the resultant force. So our A is the first force, which is 200 pounds, and our B will be 150 pounds. So minus 2 times the product of the two forces times the cosine opposite angle of our resultant force, which is 75 degrees. And then we will not be using the alpha here as of this moment. Okay, so later we will use this one to solve for the the direction or the angle between the u-axis and the resultant force. So if you're going to use your calculator, uh, the resultant force will be equal to 216.73 pounds. So that is how to solve for the resultant force. Okay, next, in order to solve for the direction or our theta, the angle between the u-axis. So let us here the angle between the u-axis and the resultant force. Let us going to solve first for the alpha. Okay, so we know that the easiest way method or the easiest technique or method to solve this one is using the sine law, since we have uh, three forces given, including the resultant force, and then we have also given the opposite angle of our resultant force. So it is now an easy step to solve for the alpha or the opposite angle for the 200 pounds force. So here, 200 divided by the opposite angle of 200 is, let's say this is alpha, is equal to the resultant force divided by the sine of the opposite angle of our resultant force, which is 75 degrees. Okay, so let's going to cross multiply, and then this is 216.73 sine alpha. Again, alpha is the opposite angle for the force 200 pounds, and it is equal to 200 times sine 75 degrees. So let us divide both sides by 216.73 in order to simplify. So we have sine alpha equals 200 sine 75 divided by 216.75. So in order to solve for the alpha, we have now the sine raised to negative 1 or arc sine times the quantity of 200 sine 75 degrees over or divided by 216.73. Therefore, our alpha is equal to 63.05 degrees. Now, the dissolution will not end here. So let us proceed to find the theta, I mean the angle between the u-axis and the resultant force. Okay, so here, so let us review. So let us get, so we know now we already solved for the angle here from the angle between 150 pounds to the resultant force. Now is to solve for the angle here between u-axis and the resultant force. So it is just easy. So alpha, we know that in order to solve for, again, so to solve for the angle or this one, the phi, alpha is equal to 60 plus a phi. Okay, so this is the alpha, the angle between the resultant force to the force 150 pounds. Okay, so this is equal to the alpha, which is equal to 63.05. So this is our equation. Alpha is equal to 60 degrees plus phi, or the angle between u-axis and the resultant force. Okay, so just use, let us substitute. So the equation goes like this. So solve for phi. So this is sorry, this is phi. So this is phi. So there's a typo error. So therefore, our phi here, or the angle between the u-axis and the resultant force is equal to 3.05 degrees.